this was an ordinary day, you would probably wake up in the morning, you would go to work, or you would take your children in the park. You probably live in a high building, you keep your money in the bank, and you drive your natural gas car. But what if this wouldn't be an ordinary day? Would you be prepared for it? Earthquakes are among the most destructive natural disasters. They are the result of a sudden release of energy in the Earth's crust that creates seismic waves. Every day, mankind succeeds in discovering something more about earthquakes as a result of the exponential development of recording instruments. Monitoring networks have been installed all over the world in order to better explain the phenomenon and help mankind become more aware of its existence. The Black Sea seismic region is an area monitored through seismic stations, which are part of 4 independent national seismic networks: Romania, Moldova, Bulgaria, and Turkey. Through the SNET project, all these stations form the virtual Black Sea seismic network, which aims to better identify and share data about earthquakes occurring in the spotted areas.
24 institutions from the 4 countries have signed a network agreement for common activities in the Black Sea Earthquake Safety Network.
It is an earthquake risk management system initiated and implemented by researchers for institutions that act in case of natural disaster. Local authorities, emergency units, but also researchers and NGOs must work together to develop direct links and transparent communication channels.
We started a very fruitful cooperation within this project, sharing information, sharing expert knowledge, exchanging the best practices between the 4 partners countries.
SNET is a unique project. We try to put our efforts and solutions that we gain already together.
If we have an earthquake in Black Sea and all the data from all these 4 countries will be gathered and we will have much rapid solution.
Nu este un proiect de cercetare tipic, mai degrabă este un proiect de transfer de cunoștințe din mediul academic în societate, în practică.
The final beneficiaries of the project is a population along the Black Sea coast, which will benefit in time to live in a safe environment.
The ability to reduce the impact of earthquakes on the society depends on the existence of a large amount of high-quality observational data. Developing the national seismic networks and setting advanced acquisition systems are essential actions for achieving this goal. Romania is a country with a medium to high level of seismicity. About 300 earthquakes of magnitudes over 2.5 are recorded yearly. The most active seismic zone is Vrancea, situated at the eastern corner of the Carpathian Belt. The National Institute for Earth Physics operates through a real-time seismic network that is designed to monitor the seismic activity in Romania.
Acest sistem este un sistem de înregistrare pe hârtie. Ce avem aici este stația de la Vrâncioaia, care transmite în timp real și datele se înregistrează pe hârtie. Toate stațiile sunt prezentate cu triunghi, dar fiecare culoare este asignată sensibilității site-ului respectiv.
Since 2002, the modernization of the Institute's seismic network has been based on the installation of new seismic stations operating in real time. The real-time digital seismic network is made of 86 seismic stations with 3 components and 2 arrays. Bukovina in the northern part of Romania with 12 elements, and Ploștina in the heart of Vrancea area with 7 elements.
Pentru Marea Neagră, în acest moment, sunt circa 15 stații seismice. O parte sunt instalate în interiorul teritoriului, iar altele sunt instalate pe zona costieră a Mării Negre.
On the Romanian Black Sea shore, the National Institute for Earth Physics operates a regional network of 13 stations, managed by the Regional Data Center that is a part of the Dobrogea Observatory. All of the data recorded by this network is transmitted in real time to the Institute for automatic processing, analysis, and dissemination. In cooperation with the Chișinău Institute of Geophysics and Seismology, several seismic stations have been installed in 5 locations in the Republic of Moldova.
Rețeaua comună de monitorizare seismică ne permite de a identifica orice eveniment seismic din regiune, mai slab sau mai puternic, cu o precizie foarte înaltă. S-a reușit reînzestrarea stațiilor seismice din Republica Moldova cu echipament seismic digital modern, ceea ce ne dă posibilitatea astăzi să monitorizăm în timp real și să facem schimb de date în timp real cu colegii din România și nu numai.
The data from these stations is received online and in real time at both national data centers. In Turkey, there are 2 institutions which currently operate seismic stations at national scale: the Kandilli Observatory and Earthquake Research Institute and the Republic of Turkey Prime Ministry Disaster and Emergency Management Presidency. There are 192 real-time stations at the moment using satellite or online communications, 9 of which are part of the ESNet Virtual Monitoring Network. The Bulgarian Seismological Network, NOTSI, was founded at the end of 1980. Its objective is to continuously monitor the seismic activity in Bulgaria and in the surrounding areas within the Balkan region. Today, the network has 14 permanent seismic stations spanning through the entire territory of the country, and 2 local networks which are deployed around the town of Provadia and around the Kozlodui nuclear power plant. 3 of these stations are located on the Bulgarian Black Sea shore and are part of the ESNet project. Data from all stations is transmitted in real time to the seismic center installed in the National Institute of Geophysics, Geodesy, and Geography. In 2 of the 4 countries members of the ESNet project, alarming systems have been developed based on the monitoring data retrieved from the stations.
În cadrul institutului s-a dezvoltat un sistem de alarmare seismică care are capacitatea de a anunța cu circa 25 de secunde înainte de a se produce unul cutremur. Sistemul de alarmare este una din tehnologiile care ajută la prevenția în cazul unui cutremur. Poate să protejeze populația indirect prin oprirea acestor instalații periculoase sau de salvarea informațiilor în cazul unor computere sau baze de date puternice. Utilizatorii care au facilități periculoase, cum ar fi gaze, instalații chimice, cu același instrument se pot bloca lifturile sau se anunță camerele de operație din spitale.
The Rapid Yearly Warning System for Dangerous Facilities, in short, REVS, is one of the first implemented European systems which detects earthquakes in real time and gives an early warning for the events detected at crustal and intermediate depth. This system has been conceived and accomplished by a group of specialists from the National Institute of Earth Physics in Romania, together with scientists from the Karlsruhe University in Germany. REVS is a completely automatic system and is addressed first of all to the facilities and technological processes equipped with the automatic self-blocking system in conditions of safety. The system is based on the time difference between the primary wave, P, which travels with a speed of around 7 km per second, and the secondary wave, S, which travels with a speed of around 3.54 km per second, and which is a lot more destructive due to the fact that it is a shear wave and carries around 70% of the earthquake's energy. A similar system has also been developed by the Kandili Observatory and Earthquake Research Institute and installed in Turkey. 100-strong motion recorders are stationed in dense settlements in the metropolitan area of Istanbul in dial-up mode for rapid response information generation. 10 stations are sited at locations as close as possible to the Great Marmara Fault in online data transmission mode to enable earthquake early warning. All together are called Istanbul Earthquake Rapid Response and Early Warning System. The system is designed and operated by Bogazici University's Kandili Observatory and Earthquake Research Institute with the logistical support of the Governorate of Istanbul 1st Army Headquarters and Istanbul Metropolitan Municipality. Shake, damage and casualty distribution maps will be automatically generated after the earthquake is produced at the data centers and then communicated to the end users within approximately 5 minutes. Full recorded waveforms at each station can be retrieved using GSM and GPRS modems subsequent to an earthquake. In spite of REV's existence, earthquakes remain hardly predictable. Scientists of all of the 4 countries are making efforts to obtain high-quality seismic data and to provide useful information to the authorities and the society. This information often reduces the impact of inevitable earthquakes. In the last couple of years, one of the main focuses of the National Institute for Earth Physics in Romania has been to obtain seismic risk loss estimations and also to give a proper image of how a major earthquake would affect the nowadays society. In the automation of the loss estimation process, a geographical information system representation became very useful in order to generate ready-to-use maps for emergency cases and a rapid assessment of the estimations. Part of the strategy for generating rapid response ground motion maps is to determine the best format for a reliable presentation of the maps, given the diverse audience: scientists, businesses, emergency response agencies, media, and the general public. In Romania, the strongest memory of a major earthquake goes back to March 4th, 1977. In that Friday evening, an earthquake with a magnitude of 7.2 on the Richter scale shook the country, producing significant damage. Based on the monitoring data, you can see here several common maps generated after the earthquake. The Peak Ground Acceleration Map, which measures the earthquake's acceleration through the ground. The Peak Ground Velocity Map, which provides the best correlation with damage, and the Spectral Response Maps. In an effort to simplify and maximize the flow of information to the public, geologists use also the modified Mercalli intensity scale, which is based on interviews and damage observations to show how severely an earthquake was felt. The Mercalli scale uses Roman numerals from 1 to 12 to express shaking intensity. Another tool which reveals important information about an earthquake is the Shake Map. A shake map provides further information different from the earthquake's magnitude and epicenter, since this map focuses on the ground shaking produced by the earthquake, rather than the parameters describing the earthquake's source. So, while an earthquake has one magnitude and one epicenter, it produces a range of ground shaking levels at sites throughout the region, depending on the distance from the earthquake, the rock and soil conditions, and the variations in the propagation of seismic waves from the earthquake due to complexities in the structure of the Earth's crust.
După estimarea hărților de intensități, în cadrul Institutului s-a dezvoltat un program de analiză a vulnerabilității clădirilor în zonele specificate, astfel încât avem capacitatea de a analiza în timp real pagubele produse de un cutremur pentru localitățile din diferite județe.
Inițial, sistemul a fost gândit pentru cutremurele vrâncene intermediare, dar ulterior am putut observa aplicabilitatea acestei evaluări și la cutremure de alt tip, în special cutremure care au loc în Marea Neagră, zonă analizată și în cadrul proiectului ESNET.
On March 31st, 1901, an earthquake with a magnitude of 7.2 on the Richter scale occurred in the Shabla seismic area. It was the most powerful earthquake ever recorded in the Black Sea. Around Mangalia city in Romania, there were reported intensities of 9 to 10 on the Mercalli scale that had significant consequences. A 4-meter-high tsunami wave affected several coastal cities in Bulgaria and Romania.
Cutremurul analizat pe această hartă este evenimentul care a avut loc în zona Shabla pe 3 decembrie 2012, cu o magnitudine 4,6 pe scara magnitudine moment. Poligoanele colorate în diferite nuanțe reprezintă nivelul la care se realizează analiza, fie nivel de oraș, cum este și în cazul orașului Constanța, fie nivel de comună. Pentru fiecare poligon în parte există o anumită culoare care reprezintă procentul posibil de clădiri care pot afecta locuitorii, rezidenții din aceste zone. Am realizat și o simulare a unui cutremur de 5,3 magnitudine. Încep să apară pagube mai semnificative. De exemplu, 2% din numărul total al clădirilor pot pune în pericol viețile omenești. În prezent, sistemul analizează județul Constanța din România și regiunea Dobrici din Bulgaria, dar pe baza următoarelor date de la recensământ vom putea extinde zona și vom putea adăuga și informații actuale.
The Republic of Moldova is located in an active seismic zone. The relative earthquake risk for the area was determined as a measure of the potential impact on the physical environment and exposed community. The aim of this study was to estimate the magnitude of damage and casualties expected in Chisinau city. To accomplish this, a simulation of earthquakes and damage to Chisinau city buildings was performed. The ESNET project focuses on the earthquakes produced in the Black Sea region. In unlucky situations, these ground shakings can generate very dangerous tsunamis.
Institutul este punct național de contact pentru zona europeană privind alertare la tsunami, pentru tsunamiurile produse în Marea Mediterană, Oceanul Atlantic, Marea Neagră sau alte mări conexe Oceanului Atlantic.
Tsunami Analysis Tool, in short TAT, is a program developed by the Joint Research Center for analyzing tsunami events. It uses a similar concept as the earthquake early warning system and sets the alarm for any seism of magnitudes over 6.5 and below the water epicenters, which could easily lead to a tsunami. TAT analyzes seismic events in the Black Sea and worldwide. It is part of the Global Disaster Alert and Coordination System and estimates the height and the transmission time of a possible tsunami wave within just a few minutes after the detection of an earthquake. TAT registers in real time the level of the sea and represents an important tool in the tsunami analysis as it uses information from the Deep Ocean Analysis and Reporting on Tsunamis Network, the National Oceanic and Atmospheric Administration, and the Sea Level Monitoring Facility within UNESCO's program Global Sea Level Observing System. Earthquake simulations are proving to be useful for all parts concerned by this problem. The geologists and scientists can improve their monitoring tools in terms of information quality and speed. The authorities and the emergency response units can get a more accurate image of the risks and can find solutions for efficient interventions. The result? Ordinary people feel more secure and their property is better protected. The monitoring institutions in all countries work to obtain the best seismic data, but after an earthquake, it all comes down to how people react and how well prepared is the emergency response unit to face the damages. The ESNet project is meant to reduce the impact of strong earthquakes by establishing a strong collaboration between the local authorities and the institutes that monitor the seismic activity.
Cel mai mult ne-a bucurat interesul Institutului Național pentru Fizica Pământului de a colabora cu autoritățile. Prefectul conduce în cadrul județului Comitetul Județean pentru Situații de Urgență. Și e vorba de orice fel de situație de urgență, că este inundație, că este îngheț, că e vânt și ajungem la cutremure.
Interacțiunea Institutului cu autoritățile este una directă, prin acces direct la portalul de analiză și de informare, astfel încât în cadrul Guvernului și în cadrul Inspectoratelor de Situații de Urgență din sudul României există terminale care sunt conectate permanent la comandamentul seismologic din Măgurele. La fiecare inspectorat de situații de urgență avem câte un echipament care arată mărimea tremurilor în cazul sistemului de alarmare seismică. Dacă magnitudinea este între 5 și 6 se aprinde culoarea verde, dacă este între 6 și 7 grade Richter se aprinde portocaliu, peste 7 grade se aprinde roșu și sună acest echipament.
Sistemul a fost implementat în anul 2013 și își propune să ne anunțe cu cel puțin 25 de secunde înainte de manifestarea undelor primare a cutremurilor de pământ, având ca sursă zona Vrancei. Sistemul are în compunere o consolă și o unitate hard, un soft specializat. Acestea permit ofițerul de serviciu din Specialatul Inspectoratului de Situații de Urgență să ia act de existența producerii unui cutremur puternic de pământ.
The Emergency Response Unit is often helped in its interventions by the Red Cross volunteers. In Turkey, the mentalities have grown to accept the fact that all types of disasters, and especially earthquakes, are the result of natural and social processes.
Turkey is an earthquake-prone country affected many different times by very strong earthquakes. The ESNET project reached the real beneficiaries who are the real vulnerables from the earthquake. And this is an action that needs quick coordination, decision-making, taking risk.
Vor fi organizate în fiecare din țările participante exerciții, traininguri speciale pentru specialiștii de la situațiile excepționale, lucru care, fără îndoială, va contribui la sporirea capacității de reacție a acestor unități la viitoarele cutremure puternice.
În cazul unui cutremur, echipajul de descarcerare poate interveni prompt cu spitalul mobil și cu toate accesorile din dotare autospeciale. Echipajul este pregătit și echipat cu accesorii și utilaje pentru salvări, pentru ridicat, salvări de înălțimi, de la nec, din spații închise, pentru deblocări uși și ridicat greutăți mari.
Cu această autospecială putem interveni în caz de accidente nucleare, chimice, radiologice și biologice. Este o autospecială de decontaminare cercetare. Avem calculatoare cu care putem vedea probele care s-au luat. Avem sonde alfa, beta, gamma. Avem pe parte chimică ChemPro fix și unul mobil.
Câinele percepe peste 500 de feluri de mirosuri. Am primit în dotare cățelușa Mara, care are 1 an și 2 luni. Este la stadiu de predresaj. O să fie specializată pentru căutarea persoanelor aflate sub dărâmături și care sunt imobilizate la cutremure, ca să le depisteze și cu ajutorul nostru să fie salvate.
The Disaster Preparedness Education Unit at Bogazici University's Kandili Observatory and Earthquake Research Institute was initially established a year after the 1999 Kocaeli earthquake through the Disaster Preparedness Education Project. The goal of the project has been to contribute to the efforts of preparing Istanbul for the likelihood of a destructive earthquake. It seems to improve public disaster awareness, local preparedness, and first response management in order to decrease the loss of life and property in case of a major earthquake. The National Institute for Earth Physics has always been open for educational visits to the Institute's facilities and to give short talks regarding earthquake monitoring actions. The National Institute for Earth Physics hosted several groups of student visits at the request of the Educational Science Institute, which developed several such educational programs in the last years. During these visits, many students have learned about Romania's seismic network and have discovered many things about earth science, including earthquakes and their risks. The Institute received more than 500 children and teachers from all over the country during different school events, such as Another Kind of School or Earth Day. Teaching all citizens, from children to students and even to adults, about how to react properly in case of an earthquake could make the difference, which could save their lives. Proper reactions, represented by an efficient preparedness of the emergency response units, can save many lives and properties. The faster the intervention, the proper the equipment, the better the training of the men implies more lives saved and less destruction occurring in the emergency areas.